In this video, we are going to use ESP32 to control the position of a servo using MQTT over the web using Adafruit IO service. I'm positioning it at 33 degrees, 180, 0, or any angle that you want. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. There are many instances that you need to control the position of a servo motor, maybe attached to an arm, a robotic application, or whatever it is, and you want to be able to control it remotely over the internet, and it doesn't matter the barrier. We will be connected via Wi-Fi, and this device is not connected to anything. It's powered up with a battery. This is the SunFounder's extension board with the battery with built-in charger, so you're just putting it stand alone and you just need to charge the battery. It has a this can be charged via micro USB, so you can send to any angle that you want. We have, in previous lesson, we learned how to control the position of a servo with ESP32, but in this video we are going to use Adafruit cloud service to control the position of this. Let's get introduced to MQTT. MQTT stands for Message Queuing Telemetry Transport. Why we need it? Because it's lightweight and efficient. MQTT is bidirectional. MQTT can be scaled to millions of things, and it uses a reliable messaging delivery system. It is secure, and it is persistent over unreliable network. So first we have to understand the elements of MQTT. We always need to have a broker, and we have MQTT subscriber, we have MQTT publisher, and the most important thing in the broker is the topic for which the messaging is being published or subscribed. Now this is Internet of Things from MQTT.org. And we have client, broker, and another client which is subscriber. In this case, we have a temperature sensor sends information to the broker, and the temperature is listed or queued on the cloud, and our subscriber can read or fetch a particular topic. In this case, temperature. The topic is temperature, and we read the temperature. And if we use a microcontroller such as Arduino or ESP32, in this case we use it as a publisher, and we have MQTT broker. In this case we are using Adafruit IO, and then we have MQTT client, in this case a subscriber, a mobile device or a computer. So the temperature from temperature sensor is read by ESP32, and because this acts as a publisher, we are publishing it as a topic of temperature to the broker, and it is being listed and queued there. It just waits until the request comes or the device is connected, so we can read the temperature on the screen. That's how it is used as a publisher. Now let's see how we can use it as a subscriber. We have Adafruit MQTT broker service, and then ESP32 is used now here as a subscriber, and we have subscribed to a topic called LED. And then MQTT client publisher is publishing on off to the MQTT broker. So when they touch or click on icon on or off, the information is queued here for the LED topic. Remember, this is a topic, and we can have millions of topics. So one topic is called LED. And because we have subscribed to that topic of LED, the information comes. Either that topic says high or low or on or off. Depending on that, we interpret and read the information, and we turn on and off the LED based on the action that is taking on the screen. In case we have MQTT broker, Adafruit, and we have MQTT client subscriber, ESP32, and we have MQTT client publisher. This is now our mobile device or whatever it is that you're connecting. So we are using this slider to set the angle. It goes to the specific servo angle feed on MQTT, and ESP32 reads it, and it will move the servo to that particular angle that we have subscribed. Now let's click on Adafruit IO. We're going to create an account. Click here on the sign in. Let's create an account here by sign up. So once you open an account, log in. Now once you logged in, you can click on dashboard here. After logging in to your dashboard of creating an account, click on dashboard, and let's create a new dashboard. I'm naming it Servo Angle 1. You can put some description here. The dashboard has been created. Click, and here let's create a block, create new block, and from here select slider, and here name it whatever name you want. I call it Servo Angle 1 because I might try different elements. Create. So this has been now created. Select next, and here servo minimum is 0, maximum, if your servo maximum is 180. Step size, if you set it to 10, it will go by the increment of 10. Let's set it to 1. Slider label, I'm going to the web and getting degree symbol. So this is the symbol. I copied it. You can put degree. So 100 degree, and then it has been created. Now again, click here, edit layout, and then you can increase the size if you wish. Save layout. Now let's go to feed and click on servo angle. This name must match. If you want to change it, click here on this screen. You will see the values, and here feed info, click, and you can change the name, the key here. The name doesn't matter, servo angle, but this key is the one that we are using in our code, in Arduino code. So save, dashboard. Now this is ready. Now let me do the wiring. For the wiring, we need to have male to male. This is female and we cannot attach it here. Get male to male wires. So I got this male to male from, you can insert them like this. The wire will be ready. But because this will not hold, to make sure to tighten it or put a tape. I have this DuPont wire. I'm going to connect it. I selected the same color. So I'm going to insert it to the connector. And I have the same color. I'm not going to make mistake. So the wiring is very simple. Look here, ground. I mentioned ground is connected to the ground from the last second. And then 5 volt is connected to 5 volts. This red, the last pin is 5 volts when you hold a USB this way. And then the signal pin is connected to 25. Like that, and the wiring is completed. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads, then ESP32 Starter Kit Main on the right side. Double click to open it, double click on C, double click on Codes, and here is the code. I've started the code by using the IoT6 Adafruit. I've modified it, and also I've used the Servo swing, this 4.3. I've combined them. I've written the code. This line is for ESP32 Servo. You need to install the library. I'm just copying it. Go to library, paste here, and you will see ESP32 Servo by Kevin Harrington, and click install. Mine shows it is outdated, so we could just update it here and install it. You will see install, and the rest we need to have the MQTT. We need to install MQTT. I'm selecting it and copying it. Go in here and Adafruit MQTT. You will see the install here. Install it, and that is done. Other than that, you need to install the driver for the ESP32, which I've explained it in the first or second lesson of this course. So from this ESP32 servo, we are defining an object called my servo. Pin 25 is defined for servo, so it can be connected. We are selecting a default angle. When we turn on the ESP32, it goes to this angle. This variable is holding the initial angle, and later on it can get updated. This is the minimum and maximum pulse width. You can play with this if your servo does not respond, but generally with the mini servo, this value works to set them. This includes Wi-Fi is for the Wi-Fi. This is for secure client. This is for MQTT from Adafruit, and this is for MQTT client. Enter here your SSID for your router, and remember, if your SSID is book, and if you type with lowercase book, it will not work. Respect the case, and then enter the password. This line is for the IO service, and this is the port. We are not changing them. Here we are entering our user ID from Adafruit, and here we are using the key which I just shown you. This is for Wi-Fi client, and then we are creating from Adafruit MQTT client, we are creating an object. We are passing the server port, username, and key, all the values that we have here to initialize this object. And then we need a certificate for Adafruit. This certificate, that by the time that you install it, might be outdated. So I will suggest to update it by opening File, Examples, and once you install the Adafruit library, MQTT library, MQTT library, go to Adafruit. You see multiple Adafruit, and go to Adafruit Secure ESP32. Open it and find the certificate here from line 50 in here. Maybe it will change depending on the timing. So select it and then right click, copy it, come to this code here for the servo and then paste it. Right click here and paste. So this will be updated. And here we are creating a servo for our subscription. And this is our object, which we later on will refer to, and we are passing. This is the feed that we have just created on Adafruit. This name must match, otherwise it will not work. So this AI username will be Robojax. Here Robojax feeds and then servo angle 1 or whatever name that you set. So this must match, otherwise it will not work. And then inside the setup, using my servo, we are attaching the servo pin to the minimum maximum. So this is attaching. This is the period hertz for the servo. This is initializing the serial monitor, printing this text. This is printing the SSID for the Wi-Fi, and this is initializing the Wi-Fi. And this line is checking if the Wi-Fi is not connected. Every 500 milliseconds, it will print a dot, and finally it will pass. If the connection is successful, it will print. This will print a new line, and this will print the IP address. And then this is for connecting to Adafruit with a secure certificate, and this is setting servo set callback, and it goes to this function which is at the bottom of the code. And then we are subscribing using my MQTT servo that we just defined. This is being passed here, so we are subscribing. Now inside the loop, we use MQTT connection to connect, which is at the bottom of the code, and then this is just for test. It's printing the servo angle. This variable is at the top of the code, and then every 500 milliseconds it checks. So there is a delay of 500 milliseconds or 0.5 second if it's 500 milliseconds. And this has been taken from, this was a code that I used for lesson 17. And this line, servo write microsecond, this will write the value to the servo, and servo moves to this angle in terms of microsecond period, and there is 15 millisecond delay, but this does not have any effect because we have 500 millisecond wait time anyways. Now servo callback is here, and we are getting the message. This is printing the buffer message, the whole message that comes, and this is getting the actual message, and we set the message as a string, store it in a variable because it's passed as a string, and then using this method we are converting it to integer of servo angle. Sometimes you might get a value greater than 180 or less than 0, so this is just preventing that and setting it to 0. My MQTT connect is a function that gets connected. We don't worry how it works. So this while loop checks, and it tries every 5 seconds until it gets connected. Otherwise, it will be stuck in here. It will try 3 times, and every time it decrements 3, 2, 1, and if it is 0, it stays here and it will not get connected. Otherwise, after connection, it shows connected. So that's the whole code, and this was a function that I wrote and modified for this purpose with the additional of the codes that you see on the upper section of the code. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here now it's connected. If I disconnect this, one of them disappear. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Here's a demonstration. The ESP32 is not connected to anything except the battery, and it is now connected via Wi-Fi. This angle is not reflecting because we have just booted and it goes by default to 90 degrees. I just clicked it, so it goes to 90 degrees. Now let me just disconnect this one wire, just this yellow, and let's move it. Ooh, it's holding. Now I can move it. So if I press this, it goes to 90 degrees because the default is 90, and I set the 90 in here by moving this arm. And let's go to 0. If it is connected 0, 180 is on the other side. So now, because the value might have been out of range, so it sets it to 90, 160. After half a second, it goes to the angle. It's responding very well with a little delay, but generally it works fine unless there is some delay in your Wi-Fi or in the network. And now I have connected external 5 volts, the positive and negative from my power supply is now connected, the positive to the positive of the servo, the negative is connected to the common, USB is also connected, and as you can see the angle is shown. If I select any angle, it doesn't turn off or it doesn't affect the USB connection or disconnection. As you can see, it's responding very well. 180. So you need to connect external power. Even the battery was not able to supply the proper current for this servo.